At least my clock is in 50. So thank you everybody for being here. This talk, as the title implies, is going to be about permissioning. Permissioning specifically on Ethereum and using the Besu client. Okay. I think I'm going to be talking a little bit about, in the beginning, about enterprise Ethereum and why it's important and why we should be looking at it differently from what the community, the Ethereum community, feels about that subject in general. And after that, we'll get into the details, okay? But first, my name is Felipe, and I'm a developer advocate for Pegasus. Pegasus being the protocol engineering group at Consensus. And one of the main things we do is build Besu. So Hyperledger Besu being an Ethereum client, right? Fully compatible with public mainnet and has some very interesting enterprise features built on top. So this is the content for this short 20-minute talk. We're going to be looking at that intro I mentioned, so why enterprise Ethereum is not boring. I'll quickly, in 2 slides, present Pegasus and what we do, and it's going to help contextualize the why we do the things we do them that way. And then we'll be looking at permissioning types with the help of our friend here, Fred, in the corner. And finally, I don't think we're going to have any time for demos, but if you want, you can come see me after the talk, and we'll do some live demos on one-to-one. So enterprise Ethereum is not boring. A couple disclaimers. I think this is kind of like a feeling in the community. I mean, this is what I feel sometimes, the feedback I get from the community, that enterprise Ethereum is shilling or too biz devy, and it goes against the Ethereum community's values. And I really do think it's a mistake, and we should be concentrating more on building this in particular. One of the reasons is because of mass adoption. I personally believe that we're going to get mass adoption of Ethereum type technologies through the usage of it by enterprises and companies and businesses out there. I don't think we're going to get mass adoption by end users actually just one day up and deciding to use Ethereum. I think they're going to be using it through services and applications that other companies are going to be building for them. That's my personal opinion. It's a bit controversial, I guess, but I do think we'll arrive to that state of mass adoption and from this current early adopter stage that we're in, because we're all here early adopters, through the uses of enterprise Ethereum. I also think it's a bridge. You know, these are some reasons why the internet got mass adopted back in the 90s. I personally believe, and I remember Netscape being a very, very big factor to that. And it was built by a company, and that, you know, it was just a way for normal users to use and interact with the internet at that time. And I think it's fair to say that we're at a stage in which those two are kind of comparable. Also, enterprise Ethereum isn't only private or permissioned networks, right? Enterprise Ethereum also has public mainnet use cases. Big companies out there are already, you know, building stuff or proofs of concepts or betas or just testing these features out. You know, JP Morgan, Microsoft, Samsung, etc. All of these are EY are really kind of advocating for the usage of public mainnet. And there's a very, very wide variety of solutions. It really isn't boring. It's a huge, super diverse application layer and networking and infrastructure layer that is available for developers and all types of profiles to work in today, right? So again, just enterprise Ethereum is not boring. And finally, there's potentially lots of Ethereum 2.0 use cases for enterprises to work in the future, right? Typically, one of those could be Ethereum 2.0 staking services. And the whole community is going to gain from this, right? Because imagine we get the top 10 companies in the world to stake a little bit of their market cap value into the Ethereum ecosystem. Not only are we going to gain in terms of Ethereum being more secure in terms of network security, but also it's going to produce, you know, a snowball effect in which they're going to want to, they're going to be, you know, using Ethereum, and then that produces more uses of it itself. But okay, so let's get on with it. I work at Pegasus, and Pegasus, as I said, is the protocol engineering group of Consensus. And so what we do is we work on all things protocol layer. So that means Ethereum 1.0, Ethereum 1.x, and Ethereum 2.0. In that sense, we mainly build software. Our main project, if you will, is Hyperledger Besu, which is, as I mentioned, a client, an Ethereum client, fully compatible, and has some really nice privacy, encryption, just basically nice enterprise features added on top of it. One of those is permissioning, right, which I'll talk about in detail. But the other things we do at Pegasus is help with Ethereum 2.0, and help, what I mean by that is we actually build a client as well, so it's called Teku, previously known as Artemis. And we do a lot of research in the Ethereum 2.0 space. So we're trying to advance that in the good direction, right? And on top of all of that, we offer enterprise services. So mainly support and features for enterprises to use and interact with the Ethereum network. So in other words, we really try to make Ethereum easier to work with and more enterprise ready, right? So all of our projects are standardized enterprise Ethereum. So basically, the EA defines specs today for software to work with and to follow. And Besu today follows those very strictly. I think it's the only client that actually fully complies with the EA spec. All of it has Apache 2.0 licenses, so full open source licenses for all of our projects, which is really kind of what moves this space forward, I would say. And again, production support for those companies. Anyways, so getting on with actual permissioning, I usually like to start anything with just looking up on the dictionary what the thing means, right? In this case, we can all see that permissioning is basically a system for granting authorization, right? There's many potential reasons we would want to have a permission network. This slide is cut off on purpose because I think there's many more that I just couldn't think of or that didn't fit in here. But in the following example with Fred that I introduced in the beginning, we'll just probably be just looking at this one identity requirement use case, right? So basically KYC, AML. Whether we like it or not, that's something that's present in today's world, that's something that's needed, that's the way the world works today, right? I'd love it if there weren't any KYC or AML requirements in the world, but that's not the case. So keep that in mind. There's basically 4 types of permissioning in Besu today. Local account, local node, on-chain node, and on-chain account permissioning types, right? So if you look to the left, so the 4 groups are also divided in 2 groups each. So you can either have local permissioning or on-chain permissioning. And if you look to the right, you can also have either account targeted permissioning or node targeted permissioning, okay? So in this example, we have Fred and Charlie. And Fred wants to send some money to Charlie. He wants to send $5 to Charlie. So, but the thing is, they live far away. So Fred lives in Paris, say, and Charlie lives in Toulouse. So Fred decides to send the money to Charlie using this magic internet money cloud called the Ethereum network. Of course, I think most people in this room know that that's not the case. That's not the good definition. It's more a P2P network that has trustless nodes in which we can send transactions and we can know that information is valid, right? So what Fred does, and Charlie does as well, they both create an account, so OX01 and OX02, and then Fred sends $5 to a node, and then the $5 are sent to Charlie. Of course, that's not exactly what happens. So Fred sends a transaction with a value of 5 to a specific node, and then Charlie can just go and receive a receipt of that transaction, right? So let's say Fred's been a bad boy, okay? He hasn't been very good, and we want to block Fred from the network because he hasn't done his KYC or whatever reason you'd want. So we can actually tell that node up there. So we can tell that node to block Fred's account from sending transaction or information to the network, right? So that's what local account permissioning is. It's local because it's at a machine level. So you would configure this node by node, right? So the actual computer itself, the server, the node itself, is going to be configured in order to block or whitelist, rather, addresses and accept information from certain accounts, right? So Fred, he's mad because he wants to send those $5 to his friend Charlie, and he thinks of other reasons, or other ways, sorry, to send this, and really he just wants to do it. So he goes ahead and obviously just sends another transaction to the node B, right? So node A is now blocking Fred's transactions, but node B can actually still receive them, of course, and we all know that. And in fact, not only that, but node B is also going to propagate the transaction onto the network, and even node A is going to receive it as well. So Charlie can even go and consult node A and get that receipt of that transaction itself, right? So we can actually tell node A to block node B from that, from receiving any information from that. And that's what local node permissioning is. So again, local, because we're going to modify the machine itself, and we're going to block, the target is going to be the node itself. So we're going to block the nodes through a machine config on the node. So in that case, node A and node B are separated, right? But the transaction is still going to be able to send through, and node B is going to be able to send over and propagate it to node C, and then arrive at node A. So that's when node permissioning data comes in. So on-chain, we can create a smart contract that's going to allow us to have permissions on the network in which we can add data on top of it, and we can actually tell that smart contract to whitelist certain things. In this case, we're going to tell them to not whitelist transactions from node B, right? So the whole network, network-wide permissions are going to be applied at the same moment because it's a smart contract on-chain, right? So that's what on-chain node permissioning is, very simply, right? So in this case, node B is completely isolated and he can't interact with the network. In fact, it was probably Fred's computer in the first place. So we've now blocked node B and Fred's computers from interacting with our network. But of course, Fred can also send a transaction to node C. I mean, it was easier for him to send that transaction locally on his machine, but he can also send it to any other endpoint in the internet, right? But at that point, what we can do is add account permissioning data onto that smart contract. And of course, as you've already probably understood, that's going to be on-chain account permissioning, and that's going to block both Fred's nodes and accounts from interacting with the network. So we can actually really isolate him completely from the story, right? That's the end of this little story. And the way basically this is implemented today is as follows, right? So this is the EEA on-chain account specification. As you can see, it's quite simple, in fact. Basically, our implementation is very, very literal from this, but it has a sender and a target. That's the most important parts of this slide, right? You have the address sender, which is going to be whitelisted or not into the network. And the same thing goes for EEA on-chain node specifications. It's a bit more complicated because basically you have to decode the enode URL of each one of the nodes, right? So it has to have the enode high and low, which is basically the division of this very long string, right? And the enode IP and the enode port. And all of those get integrated into this implementation into this interface, sorry, and it gets added into smart contract data. Just as a small aside, the EA on-chain node spec only utilizes just 1 bit from the 32 available bits today, and the other 31 are reserved for future use cases. But basically, that first bit over there says, 1 or 0, true or false. Is he allowed or is he not allowed into the network? As I mentioned, so no time for demo, although I did go a bit faster than I imagined. But if you want to see the on-chain permissioning demo live, just come and see me after this talk. It's not going to be on a Minitel, but probably on my computer. And we are obviously very, very thankful if you can all help us through your issues, your commits, your PRs, comments, feedback, anything. And in fact, we have that survey that you can answer today. If you do answer that survey, we'll get some really nice swag for you, some Pegasus swag. Have these nice tote bags, really sturdy, like very good quality. Yeah, and lastly, there's a bunch of links on that QR code. So there's documentation, there's repos, our wiki, the chat, basically a whole bunch of information regarding Hyperledger Besu, Pegasus, and more. And the permissioning webinar and the permissioning demo tutorial, I think, are there as well. So that's it. Thank you very much. Again, my name is Felipe, and I'm here to answer any questions you all have after the talk. So contact me in these addresses if you want. Thank you. We actually still have 5 minutes left, so if anybody has any permissioning questions or just basically any Besu questions, I can also answer them.
Hi, I have a question because I don't fully understand how does it relate to the Ethereum mainnet? Like, is it a separate permission blockchain or how does it work?
Yeah, actually, good question. I should have probably mentioned that. I assumed that was maybe known, but no. So this only works in permissioned blockchains, right? In permissioned networks. The permissioning aspect of Besu is not applicable on mainnet. The reason being is that for this to work, basically you have to deploy the network with a smart contract already deployed on top of it.
Yeah, so, but in normal Ethereum, like mainnet, you can have permissioning based on accounts. Like you can whitelist accounts, like Realty, for example, is doing.
That's exactly right.
And what is the reason to do permission nodes? Like, if nodes only process data anyway, so what is the reason to permission them?
So node permissioning is really more in the context of enterprise Ethereum. So in consortium in context, right? In consortium context, you would have different enterprises, let's say Airbus, Air France, and Iberia, I don't know. And they all want to make sure that the nodes that are participating in this network, especially validator nodes, but not only those, right, are specific entities. And so you can whitelist only specific, like pre-attributed nodes in that network. Anybody else?
Does the Besu permission system supports an integrated voting mechanism, or to update the permission settings, for example? How do we update the permission?
Yeah, good question. It's not specifically a voting system, but we do have, and we implemented a DApp that has a web UI in which you can, very naturally and easily add either account addresses or e-node addresses in order to whitelist, as you can see here, whitelisted accounts, admins, or whitelisted nodes in there. Does that answer the question?
I'm not sure, but for example, we have two companies, and they'd like to make sure the other company doesn't make the permission system doesn't change the permission system. As we need something to, I don't know, to ensure that.
I think you're referring to the admin accounts. So basically, in these contexts, in general, you have you do have a sort of like a hierarchical admin account that can actually modify these things, right? It's in these consortium networks, they still kind of trust each other. I mean, they have to trust each other because they work together, right? The data belongs to you as a node provider, so you can actually really have that data on-prem. But yeah, there are still admin accounts that will change these nodes.
Thank you.
Okay, so I think that's it. We don't have any more time. But thank you very much again, everybody.